Hi there, my name is Jonathan Ilg, and I would like to welcome you all to the talk AI for Trustworthy Zero-Touch Systems. Today I am joined by Anita Volkarakis, who is a researcher in AI at Ericsson, as well as members from the Swedish science team, Sveriges Unga Forskningsanslag, Lukas Dau, Devdutt Sengupta, and Niklas Engelhardt Önne. I will be the moderator, and at first we will hear a presentation from Anita about artificial intelligence, AI, and after which we will have a mutual discussion. Anita, would you like to start?
Thank you for the invitation, Jonathan. So today I will talk a little bit about trust the AI and how do we develop trustworthy zero-touch systems. So first, let me start with what is your view on artificial intelligence? So when someone mentions artificial intelligence, what does it come first on your mind? Is it something that has to have like a human-like face and to behave as a human? And if it doesn't do that, do we think that it's not artificial intelligence? Here we have some examples of very advanced artificial intelligence in some view. Two of them are coming from movies that represent what artificial intelligence might become. As you see, Terminator, and then we have in the middle, and then we have Transcendence with Johnny Depp. So the actor developed his digital twin, and then this digital twin can control everything in the world. And then we have something that we already exist today. This is the Pepper robot from SoftBank, which can read emotions. This brings us to what are the stages of AI. As we know, there are different AIs in the world. We have something that we call a narrow AI, and this is where we are today. So it's defined as the machine's ability to perform a single specific task extremely well, even better than humans in some way. And examples of that is playing chess. So we know that champion of playing chess can be a machine. And this is usually done by machine learning. Then if we move to the general AI that we don't have today, this is to perform a human perception task and is capable to reason. And what does it mean is that the machine is capable to take a knowledge from one domain and to transfer it to another domain. And what I mean here by domain, that can be many things. But for example, if we learn something, let's say in the mining domain, and we transfer it to another completely different domain, then we can talk about general AI. And then there is also a term that is called super AI. And then it's when that is when the machines will become more intelligent than us. So basically something that will be able to do reasoning, learning, imagination, and so on. And this is far, far in the future. So why am I talking about AI and what does AI have with telecom? Can it be applied everywhere? I think not to everyone comes as a first assumption that AI can be connected to any domain. And here we have our antennas. So we have a radio antenna. And as we see, the networks are becoming more and more complex. So when we had 2G, we had only 500 parameters per site that needs to be tweaked, need to be optimized, and so on. But as the networks became more and more complex, we see in the 5G we have about 2,000 parameters per site to be tweaked in order to have a perfect coverage, that all the users have good signal and so on. And we have a number of average sites per a mid-sized city, we have around 510. So, if you multiply this, you can see how many parameters needs to be optimized. This is something that is way beyond a typical human that can do. So we need more advanced algorithms to do so. Another example of applying AI in a telecom is if you want to inspect a radio base station. So this can be done by using different type of applications or that have some type of software inside of them that can detect, for example, errors or malfunctions in the base station. And it can even recommend how to fix that malfunction that has been detected. And if we go even further, it can be even robots doing that fix of the base stations or of the cables and so on. So this brings us to zero-touch automation. So how do we want to achieve this, all applying AI in the telecom, is by having intent-based zero-touch automation of our networks. And by zero touch, we mean that all the operational processes and tasks from the network, so that means from delivery of a network, deployment, configuration, assurance, and so on, can be executed automatically, ideally with 100% of automation. But still, this doesn't mean that we want to remove the human. We still want it to be there. Anyway, the human shouldn't be in the actuation loop. So everything should be done by the machine itself, and the human will be here with high-level intent specifying what the network or the system is supposed to do. The network will understand that intent, will transfer it into something that is, ones and zeros that it can act upon. And then the human will be also still here whenever necessary to intervene or to understand how the decisions have been made. I talked about decisions and I talked about AI, and this brings us to the other topic of trustworthy AI. So since everything will be automatic, it comes natural that we are scared whether we will be able to intervene, whether we will be able to understand, and so how the AI made the decisions. And Ericsson, as any other company, all leading companies has agreed that they are going to follow the ethical guidelines for trustworthy AI. And these are the 8 guidelines. So that means that human agency and oversight. So that means that the person will be still able to intervene when necessary. Transparency, explainability. So the actions have to be transparent. Everything that the system has done, if it's necessary, needs to be explainable. Accountability, to know, to trace where the decisions have been made and who is responsible for the decisions. Diversity and fairness, so there shouldn't be bias. The system should be stable, the algorithms should be stable, and they should be safe, so they shouldn't harm a human being. Privacy should be respected. And then social well-being, so also we should respect human rights, and also environmental, we shouldn't harm the environment. So this is the guidelines, but how are we going to achieve them? We are going to achieve them by building trust in the system from design. So AI will be part of the development of the system from design time, and it will be always following the rules, the technology pieces beyond. So all the AI algorithms, everything that we develop needs to be explainable, it needs to be safe, it needs to be verifiable, it needs to follow fairness, accountability, security, privacy, and also its sustainability. And there is no time to talk about everything, so I will just touch upon explainability and safety. How do we do them? So let me talk first about safe AI. So we know that AI can do many things, but how can we make sure that it doesn't harm anyone? So we have here an example of a car and unfortunate situation where the car has been trained to park, but basically it hasn't been trained to care, to not hurt or not, to not go over another car. So when it was made only to optimize a certain parameter. So when we talk about safe AI, we mean that not only that all the actions should be optimal, we also want to make sure that they are also safe. And one of the technologies that has been widely accepted nowadays and is studied when developing intelligent agents, which exhibit close to human behavior when it comes to actions and so on, it's reinforcement learning. So this is a technology that is seen as a solution that is dealing with the general problem. So we are training from an environment an agent by giving him or her rewards. And then when the agent is trained, it can derive a set of actions, or it can derive a so-called policy in the reinforcement learning world, which can be followed in order to execute a certain tasks. Since telecommunications systems are also stochastic and dynamic, we are also applying reinforcement learning in our use cases to derive optimal decision to improve a certain performance. And if we go back to the example that I gave at the start with the antennas, we can see that we can have agents controlling different antennas. And then when we talk about safe AI, we don't mean that only an agent should care about its own behavior, but it actually should optimize and should care about the overall behavior of the system. In order to do that, we need to go into something that we call multi-agent systems. And here, when I talk about optimal, we mean that we don't want the antennas or the agents controlling the antennas to derive coverage that is, intervening with one another. And at the same time, we don't want to have holes in the coverage. How do we make sure that in our world, in the telecom world, we have safe, intelligent agents? We do that by introducing shields. So we are developing a policy that is, or a behavior of the agents that are performing a certain task, but at the same time, if we check that a certain behavior is not allowed, then we develop a shield, and that behavior will never happen in the system. So all the unsafe actions are, towards the environment are basically blocked. Another trustworthy technology that I want to bring today is explainable AI. And first thing that comes, I think, to most in mind is explainable machine learning, which is today a very hot area. So here we have a cat, and there are many cats in the machine learning world. And so we wonder, how did the machine recognize that there is a cat on this image? So how it does, there are many tools, algorithms on the market, even open source, that can check what are the, on what kind of features this detection has been made. So this prediction has been made. So usually when we train a cat, we take a lot of, or cat or any image, we take a lot of images, and then we tag them by their, the different features that they have. So in this concrete case, if we ask the machine, the algorithm, how they detect that it's a cat, it might tell us it's because it has a fur, it has claws, and even has this shape of the ears. So this is what we call today a machine learning, explainable machine learning. But I want to point out, as I talked in the beginning, that it's not only about machine learning in the AI world. We also need to talk about actions and decisions and so on. So this is an architecture, a high-level architecture of an intelligent agent. And as you see, it is capable to do data collection. It is capable to do analytics, and then to store certain insights on top of those analytics into knowledge. And at the same time, when it has an insight, to perform, intelligence, to decide what kind of actions to perform. And when the actions are decided, then it can orchestrate or control. So learning is something that we can see to the left. So that's commonly, that's the data collection and the analytics. And on this other side, we have reasoning. So that's more of what decisions should be taken and the orchestration itself. And then we can have an explainer all over this behavior of the agent. So we can explain any parts of the behavior of the agent. We can explain how the insights have been derived to the human. We can explain, for example, which decisions have been made and why these decisions have been made. We can explain why this action has been taken. So even though a decision has been made, it doesn't mean that an action will be taken. And we can even explain the inputs from the machine learning algorithm going to the machine reasoning technique. So let me give you a little bit simplification. So what do I mean? So this is AI planning. It's a old technology maybe, but still alive. That's performing, that belongs to these reasoning techniques. So how does it do is that there is a domain which specifies facts. So everything that we know about the world, about the agent and so on. And then there is also actions that this agent can perform. And then we start with a state, and then in which we are, or the agent is at the moment. And then we define where do we want the agent to be at the end. And then we synthesize a plan. So this is a typical school example of bricks problem. So we want to place the bricks the 3 bricks on one another. And then in order to do that, we can move them around till they come into the right order. And then what we derive from this movement is basically a set of states and actions to move between those states. So this might look easy, right? It doesn't look so complicated. But look at this. Here is like a state space of even a little bit more complex system. So this is something that we have developed. It's based on a drone inspecting a base station, and a simple one. So it had lots of states. So now we cannot even see why a certain action has been taken. It's much more difficult. So what we do is we perform explainable AI planning. And we can answer questions here, like why action A, for example, has been taken at step N. Or we can check also why not an action B at a certain step. Or why this goal or sub-goal. Why did you have this goal? So we can have a good view of all the states in the system if we want to. And this kind of explanations are called contrastive explanations. Then there are even other types of explanations that we can look, they are connected to the state traces. So we can understand, we can look into the subpaths, and then we can see why and what was the decision path, and even what kind of facts support this decision path. And last but not least, this kind of explainability can be also applied to reinforcement learning, which is also explainable reinforcement learning is also a very hot topic. So we can explain why a certain, for example, state cannot be reached. So that's explaining unsolvability. And we can even check the different traces or episodes in the reinforcement learning policy or in the agent, and do introspection. So instead of conclusion, I wanted to give you these 2 funny comics, about what can the world look like in, let's say, 20, 30 years, we don't know. But what will happen if then, artificial intelligence becomes intelligent, way beyond this today? What do we think? Will this happen? I mean, what kind of actions should we perform even today so that we are not the ones that are tested for the Turing test in 200 years, for example, from today? That was all from my side, and I want to thank all the AI that has been done here. It's actually done by humans. So this is some of the humans behind the AI. Thank you.
Thank you, Anita, for your very interesting presentation about zero-touch systems and how we can achieve trust in AI. And now I would like to invite our other participants in the Swedish science team, together with Anita, to discuss the presentation and also in a general context. Can we trust AI? And in that case, how do we achieve that? So to start off, I would like to ask about general AI. As you said, zero-touch system moves in the direction of a general AI, even a super AI, where an AI does many tasks instead of just a specific one. Therefore, I would like to ask the participants, what do you think about zero-touch systems and general AI? What are the pros and cons? Can we trust it?
Well, I'm very interested in AI. I study it in my free time. I learn about it. However, I've only had experience with narrow AI, of course, doing some image recognition and stuff like that. I think the idea of general AI is fascinating. However, it's also frightening because it's able to do stuff that also we humans can do, and some things we might not be able to predict, which is also cool, but it's also frightening at the same time. However, I think that you have had a presentation now, and I was quite fascinated about those shields you had in the reinforcement learning. And I think that what I've understood from that is that if we implement enough of those shields, that maybe the general AI will be sort of in line with our human values. However, I want to ask, how do we ensure that all these shields that we apply, how do we ensure that all shields are applied and the AI doesn't do something unpredictable? How do we guarantee that?
Mm. Yeah, that's a very good question. And there exists another technique that's called verification. And we can do two things. First, we can do testing, and this is what usually has been done in the software engineering community, right? That you test a certain software and then you certify it. And I think a similar thing should be done in the artificial intelligence community, that we should do a lots of testing before we actually say that this is safe to be done. But even if we want to be more sure, we need to do verification. So that means we need to explore all the possible behavior that is there. And also, in addition to that, that's why exists explainability, so that we can, if there is something that happens that we are not sure about, that we are able to understand why it happens so it doesn't repeat.
Yeah, I agree. It's a really interesting topic, and especially this thing about shields as well, because often it happens that we think that something is obvious. For example, that we have these moral values which we know everyone should follow, but for an AI it might not be that obvious, and that is also something that we might have to consider when we think about verifiability and explainability. Yeah, so I like from a safety or trustworthiness perspective, I think that general AI it can be very useful, but at the same time, it can also be a subject for hacking. And if it is hacked, then there can also be very broad uh, effects of this, because general AI really can control large parts of our lives. For example, if we have several devices in our homes connected through general AI, that could then pose several problems if it's hacked and if it's controlled by a third party member. So yeah, what would you guys say when we think of like the hacking perspective? Would you say that narrow AI or general AI is more trustworthy?
I would say that as you're saying, one aspect of trustworthiness is the amount of control we can guarantee that humans have over the AI. And so the more control we give to the AI and the more responsibilities, of course, the greater the risks of, hacking becoming a real problem. So we have to really make sure that in every step on the way that we can guarantee that we have control. And one problem in general AI, and probably even more in super AI, is the more dystopian, futuristic view of the AI becoming self-aware. And if that were the case, and it would be able to set goals for itself based on and then continue working towards those goals that we did not set for it, then that would be a real problem. But as long as we take precautions with, shields, as Aneta talked about, then I would say, yeah, as long as we're careful, then we could really implement it in a very sustainable way. But we have to really consider how much control we have over the system at every step. What would you say, Aneta? Is that something that's possible to do?
I think so, and we can see also it started with that we are not allowed basically to play with the AI. I mean, we still need, all the companies have to follow these policies, and also we are not allowed even to do something without the consensus of the people's data. So if we have all this in place, I don't think that we should be scared. What we need to do for sure is that we have good algorithms and good technology for implementing this trustworthiness. We have advanced, and as I said, we have technologies for machine learning, explainability of machine learning, for maybe even safety machine learning. But as as the system will be able to, as AI will become more towards general AI, so it will be able to reason, that means that we will also need to go hand in hand with that to develop algorithms for explaining the reasoning process.
I have another question about explainable AI. You were talking about these graphs that look very cool. However, I wanted to ask you, when the AI makes these reasonings or tries to explain or justify its decisions, how do your team, or how does the AI or how do you justify its decision, or how does the AI justify the decision if its decision for taking a certain path is not like in line with your values? How do you modify or tweak the system so that it takes the right path and doesn't maybe go on a path that's maybe not as morally right, if you understand what I'm saying?
Yes, so first is, as I said, we need to have this constraints in the system, that it shouldn't take certain actions at all, even if they are optimal, they shouldn't be taken if they are not moral. So right, if it has the best performance but it doesn't follow the other aspects that are more important, that they shouldn't be taken. But beyond that, if a system it says that a path is better than, for example, a path that a human operator can come with, then that's where we need again explainability, so that the human operator can understand why this other path it's better than the path that he or she would have chosen. And then I think it's a similar trust that we have, we as humans, between each other. I mean, the more you know the system, the more you interact with the system, and the system is able to explain you. It's capable to tell you, like, this is why I have made these decisions. This is how I have made the training. This is why, I have all these mechanisms to block myself and so on. I think it will become more natural for humans to trust it. So then it won't be even there will be no need that we have to check every single step of it.
But to me, having to really make sure that the AI's decision is in line with human ethics, that really puts a restriction on in what areas we can use AI and to what extent we can use AI. So if we really would like general intelligence in as many areas as possible, how would we be able to work around those restrictions? Because we can't let AIs make every decision, because if the AI has more control, like if one AI has more control than a lot of humans, and that AI would make a decision which conflicts many of the human interests, but not all, then some people would think that the AI made a good decision, and some would think that it made a bad decision, and then that would not be a very effective implementation of the AI. So how would we be able to work around those problems in developing AI and making human civilization and technology more AI dependent?
Yeah, this is a, a very interesting observation. And if I may say, it's like democracy, how they make sure that one AI agent decision is better than the other agent. And I don't have an answer, I mean, to this, but I still think, it will be a stepwise process that probably we will also learn on our way. And I don't think it will come, at least at this, as it is today. I still think that we are far from that. We need to think like, okay, which agent is better than the other one. There are ways how you can measure it. I mean, as I said, like maybe level of trust, maybe level of explainability. Maybe we will need to implement some metrics to know which one to guarantee. Because there is something in, again, going back to software engineering, to other approaches, there is something that you can use as a metric to know if a certain software is better than another one. So I would suppose we could do something similar in artificial intelligence.
Yeah, I think that using AI, and when it comes to decisions and thinking of which decision is better, it's often easy to say which decision is better if it's something more quantitative. Of course, we can see the different results. But when it comes to, for example, ethics, it can be difficult to say which ethical values we should follow, because in different places of the world, we have different opinions and different views of things. And if we are going to work globally, that can be an issue too. Which morals should the AI follow? The morals from one country or from the other? So this is also a cooperation problem which might arise if different countries are willing to work together when it comes to AI.
Yes, I agree. It has to be some collaboration on this front. One country cannot develop for itself. And this is going to that guidelines that I showed that everyone should comply with if we want that we develop AI that humans, that it will be also morally good for everyone. To some extent, right? Depending how much. I mean, why I'm like answering in this way. I'm thinking like, even again, if we talk about ourselves as humans, that doesn't mean that if we think that something is morally good, that doesn't mean that everyone thinks it's morally good. So there has to be still some general guidelines, and of course, strictly no-nos. This is not allowed to do. But then, of course, there will be something that, for example, it can vary from a place to place, and then maybe you should adjust it to the culture and so on. But I also want to point out that, in Ericsson, with the telecom systems that we do, I think we are much more concrete, and our domain, I think it's much more in this position that I don't think we can go to that moral level that we are talking about now. We may need to make sure that we are not using data that is not allowed to be used, and then how we share it, security and so on. But I don't think that as it is today that we have that our networks can harm other people, for example.
Yeah, and I think you make a very good point. But in more telecom situations, I don't think that ethics would be the main issue, probably. And I think ethics would be a bigger issue in more real-time critical systems, such as self-driving cars. But in telecom situations, I think that one of the main issues that need to be thought about is bias, because if we were to implement these multi-agent systems that you talked about in your presentation, Anita, then you would have many different parts that go into the same sort of general or more general-ish AI. And then different biases from different parts could lead to very faulty general reasoning, especially if you have narrow AIs that are, maybe if you have machine learning in some parts that is trained on data that is biased a certain way, and then you have some other algorithms that are biased in another way, and then could become a conflict when you try to merge these if you do not correct in a good way for the bias.
Yes, yes, you are right. And there are also technologies that another hot area that is today that's called distributed learning, for example. And in this area, it's exactly some of the problems that you spoke are addressed. So it's like, we need to have a diversity of the data. So we need to train it on a lots of data, but at the same time, this data shouldn't be shared. So that means that all the training, everything is done as close to the device or to the edge in our case. And then it is shared, so all the insights are shared, and then the decisions are made. But the more diverse the data, then I think the better the prediction, the better the algorithms are. So this is one way I would say that we would like to avoid bias.
Yeah, I also think that one important way is also to think before that what do we not want to be biased? Because I, for example, learned about an example. I remember that Amazon had a lot of AI which they were using to judge which candidates would be good for working at Amazon. So there they used previous candidates and saw which candidates were successful and analyzed their applications. And there they saw that most of the people who were admitted to Amazon were men. So that meant that most of the people who were women later on were just shoved away directly, and that had an impact, of course. So we also need to consider that we don't want this kind of bias, and maybe that needs to be a part of the shield we were talking about earlier, that we need to tell the AI in advance that this is what we want and this is what we don't want, even in the bias aspect.
Mm-hmm. That's really good. And in this concrete case, I think it was because the algorithm has been trained, it didn't have representative examples. So then it was overfitted to select candidates based on the gender and so that's why it's very important also that as I talked here, maybe I've missed to say that yes, we can have explainability on the algorithms, but we should have also explainability on the data itself. So if I want to look at what kind of data has been used, to train it, then I should be able to do that.
I also imagine that bias, if of course we have to prevent bias as much as possible, but inevitably it will occur and it will affect systems. So in order to account for that, and what I'm trying to say is that the bias that eventually comes through the system and becomes apparent, that raises responsibility issues as well. Because, for example, in the very good example that you mentioned, Debde, then who would be responsible for this sexist bias? So that we need not only focus on getting rid of the bias, but also, try to correct for the bias that eventually enters the system.
True. Yes. That's a really good point. It has to be accountability of the algorithms itself. And it is not an easy task for sure, because, I mean, we can certify or we can guarantee for, let's say, a certain algorithm. But if you use this algorithm as a black box in another system where, it hasn't been tested with, then let's say someone else, some third party develops and tests it. So then the question is, if something happens, whether, who is responsible, even if they find out that the error was, or how to say, the bias or whatever we talk about trustworthy, I was in the algorithm itself, that was a black box. So yes, this is something. These are interesting topics that I think they are studied, extensively studied, but it needs much more study to be able to say that we have reached that point to know.
Just to add to what Niklas said, I think also responsibility is one of the, big discussions about AI, especially when it comes to systems that maybe learn for themselves in an environment and don't really use data that has already been gathered. What happens then when an algorithm makes a decision that it's only learned from its environment and no human input really, only the human has put up the shields and maybe program this algorithm. How do we then decide who is responsible for the actions of the algorithm? Is it the person that put the shields in place, the person that programmed the algorithm, or is it the algorithm itself? I think it's not an easy question to answer, and as AI gets more intelligent, I think that maybe the problems that or the decisions that the AI make will become more critical, and I think these will become questions that are going to be much more important to answer and to fix in the future as well.
Indeed. But I'm optimistic. I think it's going in the right way. We can see, especially if you see the regulations for sharing data. I think they were not there like a couple of years ago. Today we have these GDPR rules. So I think AI, if we follow these rules of how we handle the data and so on, at least we are going to, we will address some of the issues that we have. But I want also to point out that also it raises this GDPR and so on. It also raises other type of concerns, is because if we cannot share the data and if we cannot, learn from it, then how are we going to develop the AI itself? So it has two coins. You need sometimes to test in a closed environment, of course, and to see what might happen in order to avoid it.
Yeah, I agree, Aneta, with this fact that AI, we can see it in an optimistic way. And I often think that people seem to be scared of AI because they think that they're going to lose control over AI and that AI is like a competitor who will take over the world. But of course, that's not really where we are and where we'll be in the coming 50 years, maybe. So I think the most important thing here is that to see how AI can be made trustworthy. And as we discussed earlier, it's several different aspects involved in this. Although there are some things such as bias and whose responsibility it is, these things need to be controlled and regulated. It's really the positives which we should see and which can impact us in the future.
Yes, I totally agree. We need, as you said, that we need regulations for how AI can be used and how AI can be trained in order to keep a sustainable development. And so, for example, I would believe that many private companies that develop AI for consumer-based use, there would specifically need to be regulations in that environment, because that if the general public uses the AI, then that would mean that the general public is made more vulnerable and is put to the risk of getting dependent on the AI. And then if the AI makes some mistake or a non-moral decision, then the responsibility issues would really be difficult to discuss, and it would be difficult to handle that situation. So I think that regulations is the way to go. And if we properly make new laws and guidelines for how to use AI, I think that in the future it can really help develop a more sustainable world.
Okay, then I would like to ask you all one final question, and that concerns the road ahead. Wrapping up, what do you think and how do you think AI will develop in 30 years, and where in life will we be using AI? Will it only be in industry or telecommunication networks, or will we also be using it in everyday life? What do you think?
Well, I think it's it's a interesting question to answer, because if we look 30 years back in time, there wasn't much use of AI in everyday life, and now we're using it every day, even if we don't think about it. I mean, if we log on to our phones, we're scrolling through social medias that use AI to recommend posts and videos, etc. And I think that this will only become more so in the future. I think that more aspects of our life will become influenced by AI. For instance, the medical industry, transportation, logistics, etc. I think will all benefit from the use of AI. I also think that we have a lot to learn about ourselves when we start venturing into the general AI, about how we how do you say how we approach AI and how we use AI, but also how it affects us. I think that today a lot of discussion is about how AI uses us on social media and grabs our attention and optimizes for it. And I think that in the future, I think we can learn even more about ourselves and how we are influenced by AI, and also how it affects our brains mentally. And I think that we will learn a lot from it, and that we will learn a lot about ourselves.
Yeah, I agree. I definitely think that AI will improve a lot, and if we look in the last in the development in technology which has happened recently, it feels like it's gonna continue almost exponentially. However, there are some factors which will affect the development of AI. One of them is the understanding of AI among people. So if we continue with a lot of information about AI taking over the world, or super intelligent agents, then that can make the general understanding of AI very negative, and that would of course make a lot of protests against the development. So of course it's very important to have correct and accurate information about AI that is passed on to the coming generations. Another important aspect is neurobiology, for example. I think that development in other fields and understanding the brain better will also allow us to understand AI and make those connections. So if we develop that part of biology, we can also develop this part of computer science, which is a pretty cool interdisciplinary connection. So generally, I think that AI is going to become an important part of our lives in the coming 20, 30 years, although it might be slowed down a bit due to the negative view of people towards AI.
Yeah, I share both Lucas and Debdit's optimism, and I think that AI is imperative to a sustainable development, because in order to correctly implement AI and with the use of AI, we can solve more complex problems and overcome the more global problems such as climate change and overpopulation. Because at the same time that we develop the algorithms and the AIs, we also need to adapt to the situation. And so, and also AI can help make the development more sustainable as we use it alongside in the process. But and so yeah, I'm optimistic about the use of AI in the future. But I think that as we talked about earlier in the discussion, maybe AI is not, it's difficult to implement in certain areas where moral and ethics really play an important role, because we need to find ways to make the AI good for many different people, and we need to account for bias and the justification of decisions can be difficult in many different areas. So I think that we will have a development towards more general AI in some areas, but it will stay narrow but still develop in other areas. So specifically, I think that it will really help, streamline production and development of new solutions to the complex problems of today.
Yeah, very, very interesting inputs. I mean, I don't think anyone can know how it will develop in 30 years. As I think you said, 30 years ago, we didn't know that this would happen. So it's similar that now we cannot know what will happen in 30 years. But I want also to point out that the AI has been there for a very long time. And it had actually 2 winters because people lost interest in it. And now we are in the third period of the AI. And I'm thinking that it's really important that people are not scared of it, to really understand, to see it as any other technology, that it can have more benefits, actually have a lot of benefits, and that in order to not harm or to, all these negative sides that might rise, is that we make sure that we control it, especially in domains where it can harm. And I think also another step which would be really good is that people get educated about AI from early age, similar like we have today that programming, for example, becomes part of the curriculum from a very early start. I think the AI should become. But here, when I talk about AI, I don't think it should be about only machine learning. This is my main concern, how education is done. And I think it should be more general to understand that there are also other approaches to AI, so that we also have this diverse look of it, so we can continue developing in many directions, not only in one direction.
And here we reach the end of this talk. I would like to thank Aneta and the Swedish science team for their participation, and I want to thank you, the viewer, for watching.